Wow, we are given a quartic function. That's exciting, right? X cubed times an x term gives an x to the power of 4. And we're asked to prove it has a local maximum. So a maximum when x equals 9 over 4. And we need to justify it. So this is a very common excellence question because it lets us demonstrate a lot of different calculus skills. Speaking of calculus skills, let's not do any of that and let's just graph it so we see where we're heading. So in your calculator, you go menu, graph, put in the function x cubed times 3 minus x, and then you hit draw. Now if you don't see this, it's because your window is whack. So this is my settings. I went -5 to +5 and then -2 to +10 in the y direction. Cool, but you can of course scroll up and down or use the zoom button to zoom in or out. Anyway, just looking at this, it does have a unique shape, right? This is what this particular quartic looks like. If we go gsolve and hit max, we can find the local maximum at 2.25. In other words, 9 over 4. So this function does indeed have a maximum at x equals 9 over 4. Alright, that wouldn't get us any marks, unfortunately, being able to use our calculator, but it does give us an idea of what it looks like, right? It's kind of like this shape, where that was the origin, and this was 9 over 4, right? Something like that, like a chair, or something phallic, I don't know. Let's get rid of that. So let's use calculus. So local maximum, so a turning point or a maximum has a gradient equal to 0. So in order to use that fact, we do need the gradient function. So right now we're given y. If we just expand it out, 3x cubed minus x to the power of 4. So we're given the original function. So let's take the derivative, so dy by dx. The power multiplies out the front. 3 times 3 is 9. We subtract 1 from the power. 4 times -1 gives -4. Subtract 1 from the power. So we found the derivative. Awesome. Now to use the derivative, right, the gradient function, we're interested in the local maximum, which has a gradient equal to 0. So we will substitute in 0 for the gradient. Now looking at this, we're trying to find the x value, hopefully 9 over 4, right, to show it's a local maximum. This is a cubic equation, which is usually a little bit hard to solve. However, in this case, we can look for any common factors. In this case, I see x squared in both terms. So I will factorize by pulling out x squared, and we're left with 9, right? X squared times 9 gives 9x squared, and minus 4x, because x squared times minus 4x gives minus 4x cubed. So we factorized. And we did that so we can easily solve, right? For the right-hand side to equal 0, right, the product, right, times is in between there, either x squared equals 0 or 9 minus 4x equals 0. So we could write x squared equals 0, or x equals plus or minus 0, right, which is just 0, 2 times, or 9 minus 4x equals 0. Add 4x to both sides. Divide both sides by 4. We get x equals 9 over 4. Aha! That's looking good. But how do we know that this is a maximum point? Okay, ignore the fact that we actually already know because we graphed it, but how do we show that using calculus? Right, it could very well be a minimum point because that also has a gradient equal to 0. So we need to use additional facts to prove this. So there are quite a few ways of doing this. I'll show you one way I haven't shown before. So we have our solutions. So let's just, this diagram helps me, hopefully it helps you. So we have x equals 0, and then 9 over 4 is, a bit to the right, 2.25. We know, so on our vertical scale here, we have sort of gradient. We know that at 0 and at 9 over 4, the gradients are both 0. Actually, yeah, ignore my y-axis. This will be clear in a second. What we're now trying to work out is, does the function go up, down, up? Does it go up, down? Right, we're trying to find the shape. And to do that, we can pick a point just to the left of 9 over 4, but before 0, and just to the right. So let's say, what could that be? This could be x equals 1, and this could be x equals 2. Right? Because 9 over 4 is 2.25. Oh, so it can't be 2. Maybe 3. So, right, just the next integer that's next to it. But the key is that it's to the right of our other solution. Alright, what we'll do now is substitute in 1 and 3 into our gradient function to work out what the gradient is. So when x is equal to 1, the gradient is 9 times 1 squared minus 4 times 1 cubed, which is 9 minus 4, which is 5. So when x is 1, the gradient is positive. It is increasing. Now, when x equals 3, let's work out the gradient. 9 times 3 squared minus 4 times 3 cubed, which is 3 squared is 9. 9 times 9 is 81. 3 cubed is 27. 27 times 4, 108. 81 minus 108. Oh gosh, it's too early in the morning. 9, 19 plus 8, 27, I think. That's what our calculator is for. Never be ashamed to use your calculator to check. Oh yeah, minus 27, duh. That's why you check. Cool. So that tells us the gradient at 3 is negative. So we have negative and we have positive. So just to the left of 9 over 4, it is increasing. Just to the right, it is decreasing, which tells us that at 9 over 4, therefore when x equals 9 over 4, it is a maximum. because the only way to get a maximum is if to the left it's positive and to the right it's a negative gradient. And we've shown that by picking 2 points, just to the left and just to the right. Right, so positive gradient. And then negative gradient. Positive and then negative. Cool. So that is enough to justify it. So you can start watching now, go enjoy your day, but I will show you another method if you're interested. So the other method is called the second derivative test, and it's exactly as it sounds. We take the second derivative, so the derivative of the gradient function, and then we can use that to tell if it's concave up or concave down. In other words, is it a maximum or a minimum? So again, so far we have finished the question, we're just doing something extra. Second derivative test. So we worked out the first derivative already, 9x squared minus 4x cubed. Now let's work out the second derivative, so d squared y by dx squared. So 2 times 9 is 18, subtract 1 off the power, 3 times 4 is 12, subtract 1 off the power. So that's our second derivative. Now when x equals 9 over 4, we substitute that into the second derivative, and this one I cannot be bothered working out in my head. So 18 times 9 over 4 minus 12 times 9 over 4 squared, which gives minus 20.25. Now what this tells us, since this number is negative, so therefore at x equals 9 over 4, it is a maximum. Because the negative tells us it is concave down. Right, it has this shape there, the negative parabolic shape. It's concave down, which means at that point it must be a maximum. Cool. Alright, so let's wrap up this question. So, excellence question asking us to prove a local maximum. First, we found the derivative, and we set it equal to 0. Because we know turning points, right, maximums and minimums have a gradient of 0. So that is the achieved part. We then found the x values by solving the cubic. But to do that we had to factorize it. Alternatively, you could use your calculator's polynomial solver, right, at this point here. Absolutely fine. Or excuse me, the line above, this point here. Yep, so we found our x values. Now, we found x equals 9 over 4. However, we haven't justified that it is a local maximum. So to do that, we could either pick 2 points right next to it, keeping in mind that I picked 1 because it was greater than 0. So it has to be, to the right of 0. And we found it was positive gradient into a negative gradient. Therefore, it must be a maximum. And that would be excellence. Alternatively, instead of doing this sort of gradient diagram, you could use the second derivative test. So calculate the second derivative, substitute in x equals 9 over 4, and since the gradient was negative, it is a maximum. If the gradient was positive, it would be a minimum. And if the gradient was 0, it would be a point of inflection. Right? All right. My throat's getting sore, so I'm going to stop there. Have a good day.